All right, so we're looking at the math questions, the math SAT questions, and this second question gave both of you some issues. And so let's talk about what this one is and how to read it. So this is the category, the official category is problem solving and data analysis. So this is it's a question that isn't about like your math skills so much as like your math reasoning. And so there's a lot of words to it. There's a lot of numbers to it. And I'll show you how I would read this. And what I like to do when there's like long questions is make like an abridged version of it. So I'll pull out all the important information and say like, what's it actually asking me? So let's read through this. So a research assistant randomly selected 75 undergraduate students from the list of all students enrolled in the psychology degree program at a large university. So that's a lot of information, but there's two really important parts of it. And that's number one, that we have 75 undergraduate students, and they're all in the psychology degree program. Everything else is kind of just filler in here. So this is 75 psychology students. Okay, so the research assistant asked each one of the students, how many minutes per day do you typically spend reading? The mean, and we'll talk about that word in a second, the mean reading time in the sample was 89 minutes, and the margin of error, that's the other one we'll talk about, for this estimate was 4.28 minutes. So the mean, and you might have heard this before, the mean is just the same thing as the average. We don't need to make it any more complicated than that. So the mean is the same thing as the average. So if you were to take, I think we all know how to compute this. So if it's like two people, one person reads 70 minutes a day and the other person reads 80 minutes a day, you would add those two together. So 70 plus 80 is 150. And then you would divide it by how many counts you have. So that's like two students. So 150 divided by two, that's 75. So like the mean reading time between those two students would be 75 minutes. The one that you might not have heard much about is this idea of a margin of error. A margin of error is a measurement that says, we don't know an exact amount here. So we use this symbol. It looks like this. It's a plus and a minus on top of each other. And that's literally what we say. We say plus or minus. So a margin of error. So if the mean is 89, and the margin of error is 4.28, that says our average, our mean reading time is 89, but our margin of error, it could be anywhere between 89 minus 4.28 to 89 plus 4.28. So let's do this one. It'll probably be easier for me. 93.28 down here. And then I know I'm going to get this one wrong. So this is 84.772. That sound right? 84.72 to 93.28. Our answer, we can be kind of certain that it'll fall between 84.72 and 93.28. That's what our like average reading time will be. Okay, so let's go on and see what like this question now is going to ask us with this information. Another research assistant intends to replicate the survey and will attempt to get a smaller margin of error. This is the important part of the question. We want to take this number here, 4.28, and we want to make that smaller. Which of the following samples will most likely result in a smaller margin of error for the estimated mean time students in the psychology degree program read per day? What a sentence at the end of that. So we're looking at the average time students in the psychology degree program read per day. And we want a smaller margin of error. What is this question asking? We want a smaller margin of error. Here's what this question comes down to. Everyone's different, right? But some of us are more different than others. And so what we would want to do, the two things that we want to look at is a more similar, let's get a different color for that one. We want a more similar sample and errors come from having small amounts of measurements. If I picked out 5 kids on the street and I said, hey, what's your favorite pizza place? And they were like Vicelli's. And I said, okay, according to my research, everyone in Pittsburgh's favorite pizza place is Vocelli's. You'd be like, no, that's just 5 kids on the street. So a way to be more accurate about that would be for me to ask everyone in Pittsburgh, what's your favorite pizza place? And then I'll get an actual more accurate sample because I've asked the people that I'm looking at, and I had to do less like extrapolation for that. So I want more measurements. These are the 2 things that you're looking for. If you want smaller error, you will look for a sample where the people are more similar to each other, and you will take more measurements. So let's look at our where's my annotate? Turn annotate off. Let's look at our choices over here. So we have, can I like hide my annotations? Do you think I can do that? Hide. No, I don't think I can. I'm just gonna have to clear this story. So let's look at our answers. 40 randomly selected undergraduate psychology degree program students. So we're looking at the difference between the answer and the sample that we took. So our sample was 75 undergraduate students from everyone in the psych degree program. So we took 75 students and instead we want to do 40. And that's asking fewer people how many hours they read per day. And so we would not expect to get a more accurate answer. We'd expect to get a less accurate answer because we're taking what used to be 75 and we're shrinking that to 40. So that doesn't seem more accurate. The next one is 40 randomly selected undergraduate students from all degree programs at the college. So number 1, we're taking 75 and we're making it 40. And we are taking the undergraduate students from psych degree programs and turning it to all degree programs. So not only are we shrinking our sample size, we're taking what used to be a very similar group of people and making it a less similar group of people. Psych degree students to all degree students. So that's not going to get us more accurate either. Point C is 300 randomly selected undergraduate psych degree program students. So that's taking 75, turning it into 300, taking psych degree program and keeping it as psych degree program. So the same level of similarity between the people in our sample, but we're just asking more people. That is going to get us, we can expect to get a smaller margin of error with that because we have a more similar group of people and we have more of them to take measurements from. So that's a candidate for our answer. I got to scroll down here for the next one. Hold on. It doesn't help that I like Zoom's annotation thing is not agreeing with me right now. And then the final one is 300 randomly selected undergraduate students. So this C is our top candidate right now. So 300's right, same amount. And then we're going all degree programs instead of just psych degree programs. So it's the same amount, but from a wider group of backgrounds. So we're asking the business majors, we're asking the biology majors, we're asking all of these students, how much time do you spend per day reading? And so what that's going to give us is a greater margin of error than what C would. It's arguable whether that would give us a greater margin of error from like the initial 75 students. Ooh, I can do it like that. Remember that for next time, everyone. Anyway, so it looks like C is our answer because we have more sample or more students to ask. And they're all in the same degree program. So they're all pretty similar to each other, or we could assume they're more similar to each other than if we chose all degree programs. And so I'm going to say that the answer is C. Let's check to make sure that I didn't mislead you here. And yep, the right answer was C. Is there any other information down here? So margin of error is likely to increase with a smaller sample size. That's what we were talking about. We want more students to ask, not less. Also, undergraduate students from all degree programs at the college is a different population. And therefore, the impact to the mean and the margin of error can't be predicted. So these are totally different students. And so we don't really know how that's going to impact our margin of error. But we can honestly expect to see a greater margin of error if we're asking students from different backgrounds. Anyway, so that's question 2. The 2 points that we're really pointing at here is that we want to ask as many people as we can from as specific as a background if we can, if our goal is to reduce our margin of error. How do I stop the recording?